Okay, today we're going to have trigonometry and area, which means we're going to be using the trig to help us. And here I have my triangle, and I've labeled my vertices A, B, and C, and I've marked angle C. And this is derived from the area of a triangle formula, but we don't have our height. We have our base, but we don't have our height. So I'm going to draw in my height. And there's my right triangle. So I have angle C and I have a right triangle now, and that represents my height. Okay, if I take vertex A and go across the triangle, that's going to be side A. And if I look at B and go across, that's going to be side B. So side B is the base of our triangle, and side A is going to be the hypotenuse of my right triangle and the length of that side. So what does that do? Well, if C is my theta, and that's my angle, then I would label my height side my opposite side for trig. Okay, so according to theta, my opposite side would be the height, and my A side would be my hypotenuse. Okay, so that would be my hypotenuse, and the height could be found by taking the sine, because sine uses opposite over hypotenuse, of my opposite side of my theta, which is going to be angle C, and that's going to equal opposite, which is my height, over my hypotenuse, which is my side A. Now I need to solve for h, because h is the height, and that's the piece that I need. And in this situation, I would cross multiply. And my height is equal to A times the sine of C. And that's what I'm going to use to replace in the formula. B is going to be the base, so in this case, it's still going to be B. And then the 1/2 stays the same. So I get an area formula when I'm given just a regular triangle and I'm given 2 of the sides and the included angle, which means I have a side angle side. I have the area is equal to 1/2, and this is a side length, B, times side length, A, times the sine of C. Okay, so when I look at example 1, I have angle A, I have side length B, and I have side length C. But I still have a pattern of side angle side. So the formula changes just a little bit because I'm going to be multiplying my side lengths. So I'm going to have B times C, and then times the sine of the angle, which is A. So then I'm just going to substitute in my values, 1/2 times 17 times 12 times the sine of 48 degrees. And I'm going to put that in the calculator. And when I put that in the calculator, I get an area of 75.80 units squared. And that's my area. When I look at example 2, I didn't write my side lengths on there. My side lengths are 8 and 13. So I have angle B this time, and I have side C and side A. So the area formula could be 1/2 times A times C times the sine of B. Okay, and these are just the 3 different forms of the same formula when the triangle's labeled differently. But the pattern here is I still have side angle side, and I'm going to multiply side A by side C. So I have 13 times 8, and then times the sine of the angle, 82. And then I just type that in my calculator, and I type that in, and I get 51.49 units squared. And that is going to be the area of that triangle. Okay, I have a couple of more examples. Okay, so I want to reinforce that pattern, that it's side, angle, side. So I have my side, my angle, and my side, and my area is going to be equal to 1/2 the side times the side, so 8 times 15, times the sine of the angle, 25 degrees. Now I've been asked, what happens if I switch these? Switching them is okay because that's the commutative property. And the commutative property says I can multiply in any order. So switching those, having 15 first and then 8, isn't going to change the answer. Well, then all I need to do is type that in my calculator, and I get an area of 25.63 units squared. So again, I'm reiterating this pattern that it's side, angle, side, and I'm taking half of the side times the sine of the angle. So when I get to example 4, I have side, angle, side, and my area is going to be 1/2 the side, 23, times the other side, 18, and times the sine of the angle, 60 degrees. And again, I'm going to type that in my calculator, and I get 179.27 units squared. And that's going to be the area of the triangle. So we're kind of using a different form of the triangle. Instead of base times height, we're using 1/2 side times the sine of the angle. And that's the pattern that repeats. Okay, so the other piece is we have regular polygons, and we have example 5 from our previous notes on how to do that. So some of the problems that you may encounter would be a regular polygon. In this case, I was given an 8 for a radius. And I had to draw my apothem because our area formula requires the apothem for this type of problem and the perimeter. And I used my formulas about interior angles to find the measure of each angle here, which was 108. And that radius splits it in half for 54. And then I can use trig. So 54 degrees is my theta. That makes the apothem my opposite side, and that makes my adjacent side part of my side length. So I set up a trig function. I have opposite and hypotenuse, so that's a sine function. And I have opposite over 8. And again, we cross multiply, and I get 6.47 for my opposite side, which is my apothem. And then I set up for my adjacent side, that's adjacent over hypotenuse, so that's cosine of 54 equals adjacent over hypotenuse, which is 8. And similarly, I'm going to cross multiply, and I get 4.7 for my adjacent side. And that's just going to be from the apothem to the radius. That's 4.7. So to get the entire length, I need to double it, and I get 9.4. Now I need my perimeter. So now that I know that each side length is 9.4 and I have 5 equal sides, my perimeter is 47. And now I can use my area formula, 1/2 times the apothem times the perimeter, 1/2 times 6.47, that's where the opposite side came in, times 47 from the perimeter, and I get an area of 152.045 units squared. Okay, so those are the two types of problems that you will be having today.